The project in this complete video remains the same as the basic version of this episode. The student is using a red-green-blue LED to cycle a fade starting with blue and going to red and then continuing the cycle. This image is what is expected of the project. But the student brought this, which did not light at all. Here's the code. Pause and see if you can find the mistakes. The power is disconnected and the rails are fine. The problem here is that the student has connected the red leg to ground instead of the cathode to ground. This is correct. First, the pin mode loop increment should be 2 plus signs. Next, the blue to red loop should have semicolons to separate the arguments. All of the compensations are multiplied. Given that red is brightest and has a compensation of 2, the compensation coefficients should be calculated as a quotient. And we can see the student did not use autocomplete because the delay variables are wrong case. Last, in the red to blue loop, the red should change by just the step. Adding 255 makes the value wrong. To summarize the solution in hardware, we now have the current limiting resistor going from the RBG cathode to ground. In software, the pin mode loop increments properly and the blue to red loop has the semicolons separating arguments. The analog right value is the result of dividing the compensation factor and the case is correct for the delay variables. Last, in the loop of red to blue, the red is just the step value. Here's a tip. Most colors of LEDs vary slightly in their luminosity for a given voltage and current. To get a good color balance from the RGB, we need to compensate. A common way is to multiply or divide by a coefficient, like in this code. An alternate approach compensates in hardware by adding different values of resistors on the anode side, but that's much more difficult to adjust than in software. And here's your master's challenge. There are 2 mistakes in the code.